is going to be, it's going to look something like this when you're done, where you've got a statement here and a statement here, and then we say, okay, those two things come together to make this statement, and that branches off to create this statement, and then with something new over here, they kind of come together to make another statement, right? You've seen flowcharts in other courses, correct? Okay. And we'll see a lot of flowcharts in this class when we start talking about quadrilaterals and parallelograms and all that kind of junk. But a flowchart for a proof is very similar. Okay. Now we've dealt with T-charts, right? Where we've had basically our statements over here and our reasons over here. Okay. So we go 1, 1, 2, 2, and all that kind of stuff, right? But we might come down to like statement 3, statement 4, statement 4, and we want to create our fifth statement. And when we create our fifth statement, we might be using, statements 2 and 4 together to create 5. Okay? In a 2-column proof like this, or a T-chart proof, my voice gets, I hit puberty, I think. When these two things, I'm using 2 and 4 together to create 5. In a 2-column proof, it's not always obvious to the reader maybe which 2 steps you combine to create a new one. Does that make sense? Where with a flow chart, you'll have like a statement here. Let's say that statement there is equivalent to the statement 2. And then over here you'll have a statement number 4. And you'll have arrows going down and say what they kind of connect together or merge together to create. And that would maybe be the statement number 5 that you would have over here in your 2-column proof. So it's maybe a little bit more obvious of what statements you're combining together to come to a conclusion. We're going to see several flow charts throughout the year, flow proofs throughout the year. But if you approach like a 2-column proof, you're going to be okay. It's the same. If I was to do this in 2-column proof, it'd be the same statements, the same reasons. And we approach them the same way by, writing down vocabulary. What's vocabulary mean to us? Writing our given down. What's that mean to us? Fill stuff in our pictures and all that kind of stuff. So this is question 2 from that assignment, trying to give you an idea of what a flow chart is. It says angle 2 and angle 1 are supplementary. Okay. Angle 2 and angle 1 are supplementary. So if I look at these two things, that is that statement. And let me get this thing over here. So that reason would be what? If angle 2 and angle 1 are supplementary, what of those reasons that we would have what? Given. Okay. So it's a given statement. Let me see if I can use this. Yep. You get help getting there?
Water getting put on?
I don't know. I'm wearing contacts.
Probably not.
It's like the first day you ever wore contacts.
No, I forgot my eye sleeves at home.
I don't know why that's not working. All right, so that was our given. Now over here it's another statement, okay? And we're going to look and say that which angles up here are a linear pair from our picture. 2 and 3. So we're going to find on here angles 2 and 3 form a linear pair. And that's something that if you're doing this in a 2-column proof, you would have written your given down, okay? And then you would probably pull in the next step what that meant for us, and we're going to do that in the next part of this flow chart. But then we would eventually look at our picture and try to find another pair of supplementary angles, and it's 2 and 3. And the reason we had to be supplementary, we know they're supplementary, is because they're a linear pair. So this is very similar to what we would have done in a 2-column proof. So now you see they put those arrows down, and from this statement here, we're going to get this direct statement. 2 and 3 are supplementary. Okay? Well, that reason 2 and 3 are supplementary is because of angles that form a linear pair are supplementary. Okay? And you see some options here. There's some things that are pretty tricky, I think. Some people say definition of linear pair. The definition doesn't have anything to do with the angles being supplementary. Okay? The definition of a linear pair is 2 adjacent angles whose non-common sides create a straight angle. Okay? It says nothing about the word supplementary. We're looking at this. It's the linear pair posture. Angles that form a linear pair are supplementary. So we click that, and then over here, okay, with that statement, with that given statement being supplementary, and this thing here, this statement, you see this little arrow here in the middle. So they're taking this statement that we just developed and this statement here and combining them to come up with something new, okay? Well, if I've got 2 and 3 being supplementary, and I also have 2 and 1 being supplementary, okay? 2 and 3 are supplementary, 2 and 1 are supplementary. The common angle in there is angle 2, isn't it? So what does that tell you about 1 compared to 3? Here it's telling you why. Supplements of the same angle are congruent. Is 1 the supplement of 2? Is 3 the supplement of 2? The same angle is 2 up here and over here. So it tells us 1 and 3 are congruent. Remember back, called that the congruent supplements theorem. Back in section 9 of 2.5 and 2.6. So check that answer. Awesome. Okay, so now we got a flow chart. Okay, so now from that, if 3 and 1 are congruent, which is what we're saying here, from that information, 3 and 1 are congruent. What's that tell you about lines A and B that we talked about yesterday? It had to be what? They had to be parallel. Now the reasoning, what kind of angles are 3 and 1? Corresponding. So we need to go through this and find the statement that says if corresponding angles are congruent, then the lines are parallel. That's my answer, and we're good to go. Okay. We did last period. That's why I wanted to do this question. Last period we did the first one. So if you struggle on the first one at home, that video for 4th period will be up. What I want you guys to be kind of